Whenever you have a set of data values, a natural question to jump to is, well, what is the average of the data values? But before you can even answer that question, you have to first ask the question, what does it even mean to be average? And that's what we will seek to discuss in this video. It turns out that there are three types of averages. We will introduce these three types of averages in turn, and as we do so, there are three questions that we want to ask. First, how do we find this average? Secondly, is this average influenced by extreme values, or what we call outliers? And finally, if this average exists, is it necessarily one of the data values? The first average that we will discuss is one with which we are often familiar, and it's called the mean. So how do we find this average? How do we find the mean? Let's consider a few examples. If we wanted to find the average age of people in the room, we add up the ages of everyone in the room. These would be our data points. And then we divide by the number of people in the room. In general, then, this leads to the following formula. If I wanted to calculate the average or the mean, I sum up all of the data points and divide by the number of data points. Because we talk about the mean so much, we actually have a symbol to represent the mean. And when we're dealing with a sample mean, we use the notation x with a bar over it, or what we'll call x bar. This represents the sample mean. When we're dealing with a population, we'll use the Greek letter mu to represent the population mean. So at this point, we've pretty much covered the question, how do we calculate the mean or the average of a data set? But not completely. What happens if instead of being given the direct values for a data set, we're given the table of frequencies? In this situation, in order to calculate the average, we'll do what is called a weighted average or weighted mean computation. So let's actually calculate the weighted mean for this specific data set that we have right here, where I have the 1 occurs 2 times, I have only one occurrence of a 2, one occurrence of a 5, and so on and so forth. How do we calculate the sample mean, or x bar, in this situation? What we do is we take in the numerator of our fraction, instead of simply adding up all these values, we have to take into account that we have multiple occurrences of some of our values. So we're going to do the frequency of a value times that value. So I have 2 occurrences of the value 1 plus 1 occurrence of the value 2 plus 1 occurrence of the value 5, and so on and so forth. So what number goes in the denominator of this fraction? Typically we divide by the number of data values. In order to acquire that, we total up the number of frequencies. So if we add up this column, we obtain that there are 10 data points. So we place a 10 in the denominator of our fraction, and if we perform our multiplication and our addition, we obtain 60 over 10, which is equal to 6. So that is the mean to this data set that we have here represented in a frequency distribution. So now let's answer the second question. Is the mean influenced by extreme values, or what we call outliers? To answer this question, let's return to the example of the average age of people in a room. If the room in question is a classroom, then the average age is probably something like, we'll say, 20 years old. Now, what happens if a toddler joins the room? In this situation, the average age will substantially drop. We could certainly work with other examples or specific values, but from this we can conclude that the mean is influenced by outliers. What about the third question? If the average exists, will the mean necessarily be one of the data values? Going back to the example that we did with the frequency distribution table, we can see that the mean ended up being a 6, but none of our data values was a 6. So from this, we can conclude that the answer to the question, will the mean be one of the data values, is not necessarily. Let's now discuss the second type of average, that of the median. If we think about the word median outside the context of mathematics, we might think about medians on a road, the physical middle between the two lanes of opposing traffic. And it's this idea of being the physical middle that we want to translate to data sets. So to answer the first question, how do we find the median? We would say, well, the median is going to be the value that is in the middle of the data set if the values are ranked in order. So let us consider our small data set of 5 values right here to see an example of how to calculate the median. We have the values 5, 5, 5, 7, 8, which are fortunately for us listed in increasing order, and we have a total of 5 values, so the one in the middle is this 5 right here. So we would say that the median of this data set is 5. Well, what about the large data set? This data set, again, had the 10 values ranging from 49 up to 76, and we stop and we say, wait a second, 10 data values, where is the physical middle? It would be 1, 2, 3, 4, right here, between two values. So does the median not exist? No, the way we find the median in this situation is we actually will take the mean of the two that bridge the middle. So we would get 65 plus 68, divide that by 2, and that gives us 66.5 for the median of the large data set. In a similar manner, if we wanted to go back to our example where we were given the table of frequency distributions, how would we find the median of these 10 data points? We would count 1, 2, 3, 4, 5, and 6. The 5th and 6th values, or the two that bridge the middle, are both 7s. So the median here is equal to 7 plus 7 over 2, which is 7. So that answers the first question, how to find the median. But what about the next question? Is the median influenced by outliers? Since the median really looks at the physical middle of the data set, throwing on an extreme value of, say, 100 to this large data set is not going to shift the middle by all that much. So the answer is no, not really. The third question we should ask about medians is the median going to be one of the data values? From just these first two examples here, we can see that in this situation, yes, the median was one of the data values, but especially when you're dealing with an even number of data values, the median might not necessarily be one of the data values from the set. So the answer here is not necessarily. So now let's discuss the third type of average, that of the mode. The mode is really defined to be the data value that occurs most often or most frequently. So how do we find the mode? The simple answer is we look for the value that occurs most often. So if we go back to our small data set, the 55578, it's quite easy to see that the value that occurs most frequently in this set is the 5. It has a frequency of 3. So here the mode is 5. Well, what about the large data set then? With the values ranging from 49 up to 70. As we scan the data set, we have a candidate of 55 because it has a frequency of 2, but we notice that the value of 68 also has a frequency of 2. And so we go, well, wait, do we not have a mode? No, the answer is that we have, in this situation, 2 modes. We have a mode of 55 and one of 68. Well, if we can have 2 modes, can we have 3 modes, 4 modes? What are the rules on modes? It turns out that you can have 0, 1, or 2 modes, depending on the data set. In the initial example up here, we had a single mode. Down here, we have two modes. But if we ever run into a situation where we have 3 or more values all occurring with the same high frequency, then we actually have no modes. Identifying the mode when you're given a frequency distribution table is fairly simple. You simply scan the frequencies and identify the value that has the most frequencies. In this situation, our mode was 9. So on to the second question. Is the mode influenced by outliers? Since the mode identifies the value that occurs most frequently, if I throw in a really high number, again, suppose we throw 100 into this data set here, that's not going to change the values that occur most frequently. So the answer is not really. And the third question, if the mode exists, is it necessarily one of the data values? Simply by nature of the fact that the mode identifies the value that occurs most frequently, the answer is yes. The mode must be, if it exists, the mode must be one of the data values from the set. So in this video, we've covered the 3 different types of averages, and I hope that this video has allowed you to get a better understanding to the question, what does it mean to be average?